The reason why we are turning off the lights is because we have lots of videos here that I want to play because it's all about video and video quality, and I want us to watch the videos as well as possible. Okay, yeah, no, that's good.
How's that?
So I think the topic is fairly simple. I'll keep it light. I've been often told that I tell a lot of researchy stuff, so I'm going to try and not do that today and keep it as light as possible. So who is the judge of quality? There can be different types of viewers, but we for sure know that the end viewer, your typical viewer, in science we call it naive viewer, is for sure the judge of quality at the end, because at the end it's the human visual system that's the judge of the quality, and you need to appreciate who's watching that. Here, I'm going to talk about that naive viewer or the typical average viewer as the judge of quality, but we certainly look at others as well as part of that. And the important part is they pay the bills as well. So viewer score is important to understand the video quality or the viewer experience. And that's what I'm going to use, a viewer score that can tell, that sees like your subscriber and puts a number to quality. That's what the goal here is. And I'm going to talk about how that can help stop bad quality video. So across all genres, across all devices, across all platforms, you want that number to stand true. You want that number to be accurate. You want that number to tell the story as your viewers are experiencing it. It's as simple as that. It does sound simple, but it's extremely challenging because the human visual system is quite complex. So I'm going to start playing videos shortly. So human visual system is quite complex at the end of the day, and not only are modeling the psychovisual side of the human visual system, we are looking at the optical and many other aspects as well. So it's important to understand that as well as possible. So at the end, you can predict that number that at the end a user is going to be thinking of after watching that content as closely as possible. Okay, so we're going to watch some videos together. So we have set up some scenarios. And there are 3 scenarios here, and I'm going to play those 3 scenarios step by step. So if we could turn off the lights, please, for the videos. So you have 3 scenarios, 3 people, Jim, John, and Jackie, 3 different locations. And when I click on this, we are just going to watch the experience as experienced by these viewers on their screens. And then we are going to break it down to understand what happened. So obviously you can see the quality is not as good. You can see tons and tons of artifacts, and me with my researcher background can name probably 25 of them right now, but that's not the interest. That's not the topic today. But as you can see, the quality is not as good, which is the message. Now let's look at another video. Again, similar type of artifacts that you can see here as well, but another person watching the content at some other location, same content generally speaking. And but like I said, the content does not have to be the same. Okay, so I'll just let the video play. And then I'll play the third one. Okay, so this is the experience of the third viewer, same content as watched by the third viewer. Okay, so now we are going to break it down to see what we can tell about the quality of the video and specifically what happened and where, what went bad. But before we talk about that, we know the experience was poor for all 3 viewers. And we want to know, first of all, how to fix it. But if we don't know what went wrong and where that went wrong, we cannot fix it. So first of all, we are going to look at what went wrong where. So we are going to look at the 3 scenarios step by step, and I will need the lights off because I'm just going to continue playing videos. All right. So this is the first scenario. So if we look at 3 points, and these are the 3 most critical points in the delivery chain. What source are you getting? What's the quality of that source that you're getting? If you're getting a source from a third party, even though it may be at 45 megabits per second, H.264 encoded, you do not know for a fact that it was transcoded to 45 megabits per second, or was it really as pristine as it sounds from the bitrate perspective. Then and this is of course the direct-to-consumer or OTT delivery chain that we're looking at. Then from the second point that is extremely important is the packaged content. Because the packaged content is presumably, in most cases, majority of the cases, you will not have pixels changed after you package the content. So packaged content, that stage is important because you had multiple steps in the middle of that, right from content acquisition. So you need to measure quality there. And then the last is as viewed by a viewer after content delivery network, after your Wi-Fi, after your all of the other stages that are in the middle as watched on the specific screen. And the experience would be different on different screens. So we are going to play that story in the first case where we saw that the quality was bad. So here, as you can see, as the source that came in, the quality appeared to be much, much better. So source is not the problem. Now let's look at encode. And here's the problem. So you can see that the encode quality is lower than the source quality significantly, and that's what got delivered to the viewer. On the delivery, on the playback side, on the delivery side, you did not have those issues. So that's point number 1. So here, encode is the problem, and when you play on the TV, you get similar experience. So the first part that's important to determine is if encode is a problem. And that's a very common question that is asked. How should we encode? What letter should we use? What encoding vendor should we use? How should we use? And all that sort of stuff, which is important to avoid these sort of circumstances. So yes, encode is a problem, but you can actually know this beforehand instead of troubleshooting it every step of the way if you had the score. And the score is telling you that story. The source was excellent. Then right after packaging or encode, your score was 36, and then as watched on a specific size TV, because the experience of that video on a cell phone versus a TV would be very different. The score was 6. Let's look at the second scenario. So in the second scenario, you have the source that is bad. Okay, so we don't need to watch it all. Source is the bad quality source. And if you look at the score, you can see 34, 34. Now, the second stage, you did go through that encoding stage. You did encode that at a lower bit rate, but any impairments added during that encoding stage did not influence the overall quality. And that's important to understand. And the final viewing experience was 32. Let's go to the third one. Here, as you can imagine, the source quality is good. The encode quality is also good, but the playback quality is where you have the issue. It's just not playing full screen for some of these settings in the PowerPoint. But if you look at the score here, the score is 89. Then after encode 79, and then 28. So for the first time. In video, we have developed the technology after 25 years of research, publishing tens, if not hundreds, of papers cited for more than 50,000 times, winning an Emmy, and going through multiple generations of professors. We have invented that one score that can help you understand your experience as perceived by that viewer, or every single viewer on a viewer-by-viewer basis, on a view-by-view basis, on a network-by-network basis, to exactly know what the viewer experience was. So you can not only understand if you are going to retain customers, but you can use that to design your customer acquisition strategies. And not only do that, you can also use the score to achieve the optimal compromise between the cost of running your video business in relation to the video quality, which is always an important question that needs to be answered. So it's available, the capability for you to use today. So we have two versions of the software that we provide. The first one is for you to measure quality at all three stages, for you to make comparisons across multiple encoding options, configurations, letters, encoding vendors that you may want to do, and then also look at your playback and content delivery performance in your lab setting. The other option that is available is in production. So the same capability we are working towards providing to the industry in production, and that capability would overlay an optimization layer on top of that for you. So if you have the score that is available, if you want to select the optimal file, optimal live source that is coming in terms of viewer experience, if you want to pick an optimal encoding or packaging partner, if you want to look at content delivery performance, your Wi-Fi performance, your display, how it would look on a specific display, you would be able to do that. So I'll very quickly show you how that is done on a specific a demo of the software, but I'll open the floor for questions after I present this slide and then do a demo afterwards. So we call it VOD Monitor Inspector for the lab use case. So it's one tool, one score. And like I said, it looks at the source quality, looks at the quality of your encode, transcode, packaged content, and then looked at the playback quality as well. That is device adaptive, and you can understand the quality of that playback on a cell phone, TV, on an iPhone XS Max, or any other device that you may have in mind. Okay. So I'll open the floor for questions and then do a demo based on the amount of time that I may have. So we can turn on the lights now. Yes, please.
So comparing this process to, say, broadcast television, I mean, at least the first steps, you fix that before you ever go to air, right? I mean, you could do the same with that, because you don't want those people to have that experience through streaming, right? You want to fix it before you present your program. So you, with your monitor, you could do that, right?
Absolutely, yeah. So you have the option to run it in whatever shape and form that you want to run it. So in a lab setting or a production setting.
So do you find that that's what your customers are doing with your system?
Many of them are. So they are regular users of the platform that want to have that question answered. So not before, and I'll take it to a step earlier than that. How do you select your partners? How do you select your capacities for the delivery platform? Do you need 6 back per second? Is that what you're going with? If you want to do per title optimization, what that would get you from quality versus bandwidth perspective. Any questions that you may have in terms of architecting that delivery platform that you need to start with first. Then when you put it together, now you need to know how it all put together right from content creation to consumption would perform. You can do that in a lab setting or production setting. And then when you have it in production, we have some very exciting set of features that I would be happy to talk about. How now you can have brain, since you have the score available, now you can automate many of those decisions and deal with many of these issues in real time. How you want to do resource allocation, how you want to select an optimal path right from creation to consumption, all that sort of stuff that you can do in real time at scale.
If I may follow up, you're showing a live example,
yes,
right? As compared to like per title encoding, you wouldn't be using that for live. Am I wrong? I mean, what you're saying is if you went and did that particular show for the first time, you'd learn a lot, and then moving forward, the next time you did a live experience, you'd know more than you did the first time.
So you have the capability available in both live and VOD. We have this platform that monitors quality in real time and predicts the score currently deployed for tens of thousands of channels in real time across multiple monitoring points. So you can enable that capability to do stuff like per title optimization for live content.
Thank you.
What's your pricing model?
So with the inspector, it's for lab and the production use cases are a bit different, but generally speaking, I would just say it's based on how much you use.
Okay, and how much it is? And
Yeah, so
if
we
can implement it more often.
Sure. So we have a booth here. So if you would like to drop by, we'll be happy to chat with you.
As a user, how do I read your score? If it's 92 and it's 89, how do I differentiate between the two?
Yeah, so that's a very good question. We as scientists working on this for over 25 years always take the most complete approach to answer that question. So we validate our score using subjective quality testing that is available publicly online and do our own testing. So we have tested the algorithms across hundreds of thousands of views, first of all. And the scale that we're using is linear, so 0 to 100, 20 points wide. So you have 20 points wide, excellent, good, fair, poor, and bad. Any delta on that scale is linear with perceptual quality. So if you go from 75 to 80, that would mean the same delta in quality relative to when you go from 65 to 70. So that's number one. Number two is we actually take you as deep as you would like to go. So we have multiple types of maps available, if you will. So there's a map that's called quality map. So that gives you a score per pixel. So if you go from 90 to 91, you can compare those two maps and see what areas improved. And when you encode, generally speaking, and go from 90 to 91, typically it's not just that the specific regions got better. Some would get worse, others would get better, and you would see that. Then we have other type of maps as well, and one of these maps is called saliency map. So it would tell you where people would look when they're watching the content. So you can actually go to all those sorts of details in this product and see what the score is, why that score is, how is quality changing spatio-temporally, and then where people would be looking, your viewers would be looking when they watch the content. So when you go from 89 to 92, you would see through that platform, but because the granularity is so high that a viewer may not say, let me watch the content and say 90, 91, viewers do not differentiate at that high granularity. So viewers generally would differentiate at sort of 10-point scales or 20-point scales. So that's then your viewers how you want to model them.
Sorry, we're doing a little bit late, and you might have covered it, but we've seen challenges on certain monitoring tools where maybe different players or different clients will throw certain response codes that might not necessarily correspond with what the end user sees. So how do you parse through corresponding certain types of responses or certain types of issues with what the actual user receives at their end? All the gotchas, I guess.
Yeah, so here we are talking about viewer experience primarily, right? Not quality of service. So quality of service is important, and we can certainly do quite a bit of that. So I would be happy to talk about that. Here, what we are looking at is, was there any impact on the viewer experience? If you switched profiles, did you see any delta in quality? So for one content, you go from profile 1 to profile 2 and would not notice any difference. For other content, you would go from 1 to 2 and you would see a huge difference. So the goal here is to model the psychovisual behaviors of the human visual system to understand how a viewer would respond. So if you go to a lower quality, you would penalize it much more than if you improve by the same amount and go to higher quality, then you say, of course, the quality got better. So it's that part that we model here. Then there's quality of service layer that we would be happy to talk about as well. Okay. So I really appreciate your time. I could not demo it here, but we have the software at our booth. I think it's 27, booth number 27. So please feel free to drop by. We would be happy to talk about the lab or the production version and do a demo for you as well.
A big round of applause for SSIMWAVE.